All right, we're going to continue looking at 5.2, which is titled Frequency Tables, Histograms, and Frequency Polygons. In other words, how do we sort information or data and put it into a bar graph or a line graph? In this one, we're going to actually interpret bar graphs. This question says, the magnitude of an earthquake is measured using the Richter scale. Examine the histograms for the frequency of earthquake magnitudes from 2005 to 2009. Which of these years could have had the most damage from earthquakes? So, we're not looking for the highest bars, because Richter scales, so the magnitudes here are from 0 to 7, Richter scales have different definitions. So if you look here, damage doesn't tend to occur until a 5 to 5.9 Richter scale. On that one we have felt by all and considerable damage to weak buildings. When we have between 6 to 6.9, there's partial collapse of ordinary buildings, and as we get higher and higher, you'll see from a 7 to 7.9, we're starting to lose lives. And above that is widespread loss of life and destruction. So we're generally looking for something above 5 on the Richter scale. So which years had the most greater than 5 roughly? So you'll see right here, there's a lot of earthquakes above 5. There's not too many. In this year there's a few, so in 2005 there's a few, in 2006 there's a few, 2007 there's a few, 2008 there was plenty, and in 2009 we had 3 between 5 and 6 and 1 between 6 and 7. So those are probably our top 2 years as far as damage made by earthquake. So the next part of the question says this, says draw a frequency polygon, in other words that's a line graph, for the number of earthquakes in each interval for the 2 years that you think had the most damage from earthquakes. So we've looked at that. The 2 years with the most damage from earthquakes are 2008 and 2009, at least that's our assumption here. So we're going to make a frequency polygon of those 2 years, or in other words a double line graph. What I've done right now is included the frequencies, so how many times they happened, and then also the magnitude from 0 to 8, so that's the intervals. Okay, so if we look at 2008, you can look above if you'd like to, if you have the study guide. If not, you're going to have to trust that the information is there above. The most damaging earthquakes. If you're doing anything with more than one set of data, what you're going to have to do is use a legend, or tell me what you're talking about. I'm going to use X's to represent the year 2008. So in this particular case, it looks like we had 0 between 0 and 1, 0 between 1 and 2, 9 here, 11 here, 16 between 4 and 5, 5 between 5 and 6, and 4 between 6 and 7. So this represents 2008, the magnitudes and the frequencies of earthquakes that occurred that year. If we look at the next example, or sorry, next year, 2009 we determined was the next most damaging year, so that would be right here, 2009. The frequencies look like this: 1, 0, 9, 14, 7, 3, and 1. So that is a double frequency polygon regarding the 2 years. So again, you need a legend and you need to title everything. The last part, and then we'll get into just the key ideas for section 5.2. Based on the evidence presented, which year probably had the most damage from earthquakes? Well, you can see here the damage is done above Richter scales of 5. So the most damage is probably done in 2008. But the next part of the question says this: what other factors should be considered when determining which year had the most damage from earthquakes? Well, one thing that needs to be considered is where they occurred. Okay, because if you had a major earthquake out in the middle of a huge plain land where no one lived, probably not a lot of damage done as far as monetary value goes. So did they happen in city centers? Did they happen in the country, etc., etc.? So we think it was 2008, but we have to consider where they happened. So the key ideas for the entire section 5.2, most of it's filled out for you. If you're using the study guide, you might want to pause these and add them in. Here's the basic key ideas for this entire section. First of all, large sets of data can be difficult to interpret. So organizing this data into intervals and determining the frequency of the data can make it easier to interpret conclusions. So we need to organize data. A frequency distribution table, which we did in the first part of this section, so first video for 5.1. It looks like this. Is a set of intervals of equal value. So in this one you can see the intervals are 450, so they're going up by 450. So the intervals have to be of equal value. Each interval is associated with a frequency, so how often they happen, that's the tally and frequency here. That indicates the number of the measurements in the interval. A frequency distribution should have between 5 and 12 intervals. So in other words, a bar graph or a line graph should have between 5 and 12 sets of intervals. Otherwise, the table or graph does not effectively show how the data is distributed. To determine the interval width, there's two ways. You could just use a guess and check method to determine these intervals, depending on your data, or you could do this. You could calculate the range of the data. You could divide the range by the number of desired intervals, and then adjust to a suitable width, or a nice interval. So use a nice number to go up by on your intervals. Each interval begins just after the first value in the interval. This ensures each value is only counted once. This hasn't been looked at before, but here's an example. So for example, if you had intervals of 0 to 5 and 5 to 10, the value of 5 would belong in the lower interval because they start right after the number. So from 5 to 10, that technically starts at like 5.1. So this would belong in the 0 to 5 interval. A few more key ideas. A histogram is a bar graph of a frequency distribution. The intervals are marked on the horizontal axis, so you put the intervals on the horizontal axis, and the frequencies on the vertical axis. The horizontal and vertical axes usually, I replaced that word, meet at 0. If the scale on either axis is not consistent, so if you're not going up by a consistent scale, so you see here it jumps from 0 to 150, and then goes up by 450s consistently, you have to have a break, just like it's here. Okay? And lastly, dealing with line graphs, a frequency polygon is a line graph of a frequency distribution produced by joining the midpoints of the intervals, so be in the middle of the intervals, that's where the point should be, with straight lines. The values on the horizontal axis can represent the midpoint or the range of the intervals, and polygons, frequency polygons, are especially helpful for comparing multiple sets of data, like here, because they can be graphed on top of each other. And we want to use different colors or symbols in order to do that.